Hi all, today we're going to enter a new chapter and it's about deformation of solids. Deformation is changes in the inner structure of solids and it deforms because of the force. Forces not only cause acceleration but can also cause changes in the inner structure of solids. Such changes are called deformations. Let us see what is meant by plastic deformation. Plastic deformation is one which material shows no tendency to return to its original size and shape when the applied force being removed. And how about elastic deformation? Elastic deformation is one which material shows tendency to return to its original size and shape when the applied force being removed. Figure shows a wire of natural length or original length of L fixed at one end and stretched by a force. The extension produced is E and A is the cross-sectional area of the wire. When any materials deforms, two things will happen. One is stress, another one is strain. Define stress. Stress equals to force per unit cross-sectional area. This is the symbol for stress. We call it sigma and the unit SI is Newton per meter square. Whereas for strain is the extension per unit original length. This is the symbol for strain. We call it epsilon and strain has no dimension nor unit because the unit SI for extension is meter and the unit SI for original length is meter. Meter cancel each other, so strain is dimensionless. The combination of stress and strain gonna give you the Young's modulus. The Young's modulus is the ratio of stress and strain. The symbol for Young's modulus is E. E equals to force times the original length per unit cross-sectional area times the extension. The unit SI for Young's modulus is Newton per meter square. Let us attempt these A-level questions to give you more confidence about stress, strain and Young's modulus. A copper wire is 4.0 meter long and 3.0 millimeter in diameter, stretches 1.5 millimeter when a body is suspended from its end. Determine the mass of the body. Given the Young's modulus for copper is 1.2 times 10 to the power of 11 Newton per meter square. When a body is suspended, the force is acting upwards and for the weight is acting downwards. The force equals to weight because the body is hanging freely and weight is mg. The force stretches the copper wire to 1.5 millimeter or extended to 1.5 millimeter for the area pi r square, where the diameter of the copper wire is 3.0 millimeter with the original length L, which is equals to 4.0 meter. Everyone knows that stress equals to force per unit area and the strain is equals to extension per unit original length. The ratio of stress and strain going to give you the Young modulus E, which is equals to force times the original length per unit cross-sectional area times the extension. The force here is equals to weight. Weight is equals to mg. I put here mg and the area is pi r square for the diameter of 3.0 millimeter and the extension is 1.5 millimeter and the original length is 4.0 meter. We're going to substitute all the values accordingly in this formula. Then the mass of the body is 32.4 kilogram. Simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot and thank you to the Lord.